not a lot of time, we will talk about this thing called the Microsoft .NET Access Control Service, which is a horrible name, by the way, and a misnomer too, because it actually has nothing to do with .NET. It was written in .NET. That's maybe the only relationship we have. And what is this thing? Well, roughly speaking, it's a security service in the cloud, in Microsoft's cloud. So why is this interesting? Well, first of all, it's a security service. We're at a security conference, so it must be interesting. Second point is it's in the cloud. So it's a kind of interesting thing to look at, because in my head we will see more security utility services in the future running not on-premise. Let's put it that way. Okay? So, as I said, horrible name, very long. I will just call it ACS or SACS, as Microsoft calls it internally. And just a disclaimer before we start. This stuff is not released yet. Okay? You can use it. You can play around with that. It's not released yet. Microsoft hasn't even announced pricing yet. Okay? Pricing is expected to be announced in June, and RTM is in November. So that is more like, think of it as having a look at maybe the first security product in the cloud. Okay? So, you know, for the first time for a long time, Microsoft were the first again. Cool. So a more technical answer to the question, what is the ACS? It's a resource STS in the cloud. If you totally know already about what a resource STS is, the next 20 minutes might be boring. Okay? If you don't know that, let's start at the beginning. So who am I? Why am I here? Well, why am I here? This question is easy. Because Enno asked me to. You don't know Enno, he's the guy running this company, and this company runs this track at the conference. So that brings me to the next question, why am I here? Who am I, sorry. Because I used to work at AMD till 2005, I think, where I focused my time basically breaking stuff. Okay? So after 5 years of breaking stuff, I decided I want to fix stuff again. So I changed gears, became independent, and now help companies fixing things, or even better, building software in a way that, well, the AMD guys can't break that much at least. Okay? So I'm focusing on security in distributed applications, so I'm an application guy more than an infrastructure guy, using the Microsoft technology stack. And maybe the most important information here is my email address. So if you have any questions after that, write me an email, and I'm happy to help you. Okay? Cool, so let's get started. So, basically I have divided this talk in 3 parts. One is a brief history of authentication and authorization, and why we are at the point where we are today. Okay? The next thing is I want to talk about this ACS. What is it about? How does it work? And how can it help us at the point where we are? And I want to show you some stuff in action. Okay, cool. So if you have any questions in between and you have the feeling I have to know the answer, otherwise I can't follow you, raise your hand. For the more general type of discussion, I would defer that to the end of the talk, or tonight at a bar or whatever. So basically, the mother of all authentication authorization systems is what I call direct authentication. So a user talks to an application, and then the application typically has 2 types of data stores, at least logically, hopefully physically too, which is all of the security-related data, things like passwords, for example, things like groups or roles and these kind of things. And we have a database which contains application data, like orders and customers, and so on and so forth. So when the user logs into this application, the application is responsible for authenticating the user, meaning going to some sort of backend store. Hopefully the guy who wrote the application knows what a hash was, and these things. But the complicated security logic is in the application itself. Okay? Now, this guy typically uses more than one application, so there's another application. And if all things are really good, these two share the same security database. As we all know, this is not usually the case. Okay? So I've just been to a customer who refactored 5 stores. Okay? all around 200,000 users, but spread around in 5 databases. And sometimes users had duplicate accounts, and sometimes they only have an account for a specific ad, and so on and so forth. So every application has to do its own security. Yeah? So if I add 5 more, then typically they will have some sort of security database. Now, if we have multiple users, then they have to go to the corresponding databases, and even worse, maybe one guy uses passwords, one guy uses certificates, one guy uses secure ID. These applications have to implement all of the authentication types themselves. Okay? Then typically applications live in some sort of scope or context, maybe like a corporate network. So how do we provision new users? Let's say you want to give partners or customers access to your application. How do you provision them? You don't know. So you create a new account here, right? Account, username, password, and hopefully we only have one shared database, so we only need it once, but as you know, in reality we have multiple of them. So basically, provisioning new users is giving them new accounts in your system, right? Which means for you, you have to take care of more accounts. You have to do things like password rotation and all these things, and it means to them, they have a new account, right? Another one. Okay, so by the way, who has less than 20 accounts in this room? Yeah, exactly. Yeah, so another one, yeah? Cool. So this is the thing we all know and love, and basically where we are most of the time. But there were also some people who said, like, okay, this is madness. Let's do something better. And that's what I call generally token-based authentication, meaning the first thing the user does is he contacts some sort of security service sitting in your network, authenticates with this central part in your infrastructure, and he gets back a token. Okay? In this slide, I specifically talk about Kerberos. So this thing is called a service ticket. Does anyone know, second question, sorry, I don't have giveaways, yeah? Second question, does anyone know what's inside of a Kerberos ticket? Who doesn't use Kerberos at work? Okay, 5 people. The rest, what's in a Kerberos service ticket? Well, besides some crypto goo, it's the username and the groups of the user is a member of, right? Okay, that means when the user forwards this ticket to an application, what the application can know about the user is, well, basically his username and the domain groups he's member of, right? Why is this a better system? Well, basically authentication only happens here. We don't have to scatter dangerous logic, dangerous code around in our networks, okay? So we can centralize authentication at a single point. If we use multiple applications, we basically only authenticate once, logically at least, with the domain controller, and then pass this ticket on to all our applications, meaning I have one account for all applications, and I have things like single sign-on, and so on and so forth. Now, is the username and the domain groups typically all an application needs to know about the user? What do you think? Well, no. Typically, applications don't care at all about these things, right? They care about maybe what's your department name, what's your email address, what's your purchase limit, these kind of things, right? So we end up again doing cross calls from the application to our security store to get these values, okay? And as developers in this room know, that typically involves writing quite unpleasant LDAP queries and these things. So we are halfway there already. Now, how do I provision external users here? It's not easy, right?
Adding accounts.
Pardon?
Adding accounts.
No.
Can this user authenticate with my domain controller if he's external?
That's on your firewall technology.
Hopefully not.
Hopefully not, exactly, yeah. So it depends on your admin, actually, yeah. So basically what no one wants to do is expose this thing to the external world, right? So the problem we have with Kerberos-based networks, and I'm talking specifically about Active Directory because that's what I mostly know, is to establish a trust with someone else, you have to establish trust for the complete network. Okay? So you're doing a cross-forest domain trust, whatever they call it these days, and that basically means that two networks trust each other. But the only thing I want to know is that this application trusts that user, and nothing else. Okay? So there are some problems with Kerberos too. Now, the thing I'm working on in the last 2 years, and maybe some know it already, maybe to some it's new, but that's definitely the way it's going to move forward, is token-based authentication using the WS star protocol family. WS Trust, WS Federation, WS Metadata, and so on. And if you look at how authentication using these protocols work, well, you think that's Kerberos. And you're right, it is Kerberos, just using angled brackets at this time, and not binary data, which gives us better compatibility, better interop, and so on. But the idea is the same. The user talks to a so-called security token service, or more specifically, they call it identity provider, and gets back a ticket. But since we don't use Kerberos service tickets anymore, we're using, well, the typical token type is called a SAML token, Security Assertion Markup Language. And the beauty of that token type is that you can put in arbitrary data. So it can hold more than a username and a group. It can hold the name of the department, the email address, and the purchase limit. Okay? So we're getting that information from that token service. And because there are so many things we can put in there, because it's arbitrary, yeah, we can model different types of security architectures. So we can model roles with that. We can model permissions with that. We can model capabilities with that. Later on, I will show you a demo where I modeled Bella Padula with that. Okay? So there's a lot of expressiveness here. Now, once the client got this token, it works exactly the same, right? He used the token, passed it on to the, they call that relying party, the application. The application cracks open the token, it is encrypted and signed and so on, yada yada. Opens the token and says, okay, the thing I really care about is your purchase limit, and it's in the token already. So there's no back-end database connection going from here to here to extract these values the application is interested in. Okay? And of course, there's a trust relationship between the application and this token service, just like in Kerberos. How do we onboard users here? You know what? It's much, much easier. Typically, what this user needs to have is also an identity provider. Okay? Also a box which can issue tokens, which uses WS star and SAML, for example, and this single application can establish trust with that token service. Meaning, technically, if you send me a token that is signed by that certificate, I will trust you. Okay? So what's the main difference here to Kerberos? We can establish trust on an application basis and not on a network basis as the smallest unit of trust. Okay? I mean, we could establish trust on the network basis, but typically we want less. Okay? Least privilege. Kind of a recurring pattern. So basically what happens is we want to have users externally accessing this application here. They have a security token service, they get tokens from this guy, they send it to us, we trust the signature, we open the token, look at the claims, and we're done. Okay? So this is basically where the industry is heading to, because Kerberos works remarkably well in intranet, it fails completely on the internet. Okay? Cool.
Sir?
Yeah.
That looks a little like Shibboleth. Do you know?
Yes, Shibboleth actually used the SAML token type.
Yeah.
And I think they are also using WS Trust and also SAML 2OP.
Yeah, out of
What?
base, no?
What?
Out of base.
Shibboleth has a number of options. But one of the options is using SAML tokens and WS Federation or WS Trust. Okay. Exactly. Cool. So this all looks good. This is basically what I'm working on every single day since the last 2 years. But this still has some problems. So let's say you're having an application, and the good thing about the abstraction of tokens and the abstraction of claims is that an application can formulate a policy saying, as long as I trust the token that's coming in, I only require to have an email and a role claim in my token itself. Okay? If you can satisfy these 3 things, trusted issuer, email claim, role claim, you are a legitimate user of my application. Okay? Fine. Now the thing is this, you start partnering with other people. Now suddenly they say, okay, we can do that, but our role claim is called department. Okay? Your other customer says, yeah, we can do that, but our role claim is called title. Can you somehow do a mapping between them? Maybe you are like an ISV type of company which wants to onboard external users extremely easy. So maybe you have to support Live ID, Facebook, Yahoo, OpenID, whatever. They have different claims again, yeah? Maybe Live ID only supports email. Facebook maybe has an interest claim, okay? The bottom line here is that the application has to do all this mapping code. Okay? So what we typically do to abstract away the application from the identities of the incoming users is a thing called a resource STS, which brings me back to my first slide. Okay? So a resource STS is basically a piece of infrastructure which takes incoming tokens and incoming claims, normalizes them, and sends them on to the application. Okay? So again, what's the reason we do that? Because we want to take away the secure, the complex stuff from the application, because applications we have many, okay, and we don't want to re-implement all that stuff over and over again. Cool. That's a resource STS. An identity provider is a token service that emits user-centric claims, whereas a resource STS is a token service that emits resource-centric claims. Okay? Now, this is the conceptual model here. Okay? The physical model is this. So let's say here's your application, here's your resource STS, and here is some partner or some customer. And they want to talk to your application. So what they do is, physically, they authenticate with their own identity provider, get back a token, send this token to the resource STS, the token is signed by him, encrypted for him, he opens the token, does the transformation logic, sends him back another token, which is signed by him and encrypted for him. And the last step is the guy forwards that token. Okay? And then he is just a normal user without the need to explicitly provision him on that side of the world. Okay? That is loosely called federation. Now, another interesting side effect here is, what happens if this guy leaves the company? Can he still access your application? Well, given that they deleted him from their internal directory, he can't authenticate, he can't get a token, and he can't talk to the application. Which is much better as doing federation manually, saying, hey, can you create an account for me? User is Bob, password is Sue. And by the way, he left half a year ago. Thanks for maintaining my dead account. Yeah? So this model is very interesting for federation and just generally for crossing security boundaries. Okay? Cool. Now, as you can imagine, this machine here, the resource STS, becomes a vital part of your infrastructure. Because if this machine goes down, no authorization, no token transformation can happen, and all of your applications are offline. Right? Because if this guy is missing, we can't talk to him. Okay? So, now, I have two types of customers which look into these kind of things. One is the typical enterprise type of company, saying, you know, we have this huge AD domain and we bought these 15 companies. Now, we really have a problem managing all our trust relationships. So, for crossing trust boundaries, we would get rid of Kerberos and use SAML instead. Okay? So we can internally broker trust between disconnected parts of the company, which are not belonging to the same AD, for example. Another typical customer for these technologies are ISVs. So basically, you are a software vendor, for example, and you want to provide software as a service to your customers. Now, when they log into your software or your service, they have to authenticate, okay? So do you want them to create a new account just for using your software, or wouldn't it be nice if they could reuse their existing domain account to talk to my application sitting somewhere? Okay? So think of the identity provider, and by the way, with Server 2008 R2, there's a built-in SAML security token service in Windows. Just like you install a Kerberos KDC, you install a SAML provider. Okay, so you will have the choice in the future, in Windows at least, do you want a Kerberos ticket or a SAML token? Okay, and both have their ups and downs. But the SAML token is the more flexible one. The SAML token is the one which can easily cross trust boundaries without, reorganizing your whole network. Cool. So, whenever something becomes very expensive to run or very vital to your business, you always have to think about, wouldn't it make sense to take that service, move it to someone else who maintains that service, who pays me money if the machine has downtime, who makes backups, who makes all these things for me, right? And that's where we get to cloud computing. So Microsoft has this thing here. It's called the Azure Services Platform. They announced that officially last November. And the first thing is they said, we now have a Windows operating system for the cloud, Windows Azure. So the first thing I thought, what the heck is a cloud operating system? And it turns out that this is not a new version of Windows, something you can buy or something they send you via the cloud or whatever. It's basically just a name for a data center. So they have a data center, 3 of them at the moment, which runs a lot of machines. And Windows Azure, in its pure essence, is the software which manages the data center. Okay? So let's say you have 1,000 machines. They have a software which can do things like manage load balancing, figure out when stuff goes down, when stuff comes up, and do routing, and do failover, and all these things. Okay? That's Azure, really. They have some nice features like, for example, fault domains and update domains. So let's say you want to deploy your application in the data center. You can say, okay, I need 2 instances of that application running all the time. So they can say, okay, so we will install 1 instance of your application in that rack, and 1 instance over there, because different rack, different switch, different router in front, so we have 2 fault domains. Okay, so basically you can have availability via fault domains. And besides running your own applications in that data center, they have a bunch of services they provide and want to sell to customers in the future, which are called .NET services. Here's the misnomer. SQL services and live services. We concentrate on .NET services, and inside of that, we have this thing called the access control service. And now, I say it again, what's the access control service? It's a resource STS in the cloud. Okay? It's this infrastructure which you might have to run on-premise, but maybe want to have someone who takes care of that and pays you money if something goes wrong. On the other hand, you pay them money if nothing goes wrong, right? So it's always a choice. And the term I like better here, especially with that service, is not cloud, but utility computing. Okay? Cool. So, now we get to the more technical side of things. So basically what happens is, if you are interested in trying out this service, for example, I can show you. You basically open a browser, well, that'll be a fun demo later on. So, and when the cloud is ready, it will give us back a page. Ooh. Okay? So basically you go there and say, I'm a new customer, then you sign in, and then you get to choose a name basically which gets part of Microsoft's DNS infrastructure. So when I sign in here, you will see, when this comes back, I have two so-called solutions in there. Come on. 1, 2, 3. And basically when you say, okay, my solution is called ERNW, for example, then you get a machine called ERNW.accesscontrol.windows.net. Okay? That's your instance of this access control service running at Microsoft's data center. At the moment, when you're going to try that, you will be fixed to a data center in Chicago. Starting with November, you will have the choice of a European data center, which sits in Dublin. And next year, they're planning to open one in Germany, which is a big legal requirement for a lot of companies. Okay, so you now have this box here. And the star here says you have endpoints under this namespace, and basically they have at the moment, that's subject to change in the sense of there are more in the future. These endpoints talk WS Trust, WS Federation, and OpenID. Okay? Now, the idea of that service is really, really simple. Some sort of token comes in, they are running some sort of rules engine in this thing, and out comes a SAML11 token that you can consume in your application when you're having, a SAML compatible toolkit, which is almost everywhere these days. Okay? So the whole idea of this service is claims go in, claims go out. Okay? The claims that go out are signed by the access control service and are encrypted for your application. I'll show you in a second how that works. Okay? Now, why is this not .NET specific? Well, first of all, these are all standards here. SAML is a standard, OpenID, and so on. And the way you program against the access control service is also in no way .NET specific. It's based on Atom, REST, and every programming language that can issue HTTP requests and can process XML, you are good. Okay. So, just to recap, the ACS is an RSTS running in the cloud and hosts a rules engine so that you can transform claims the way you like it. Cool, so let's see if we are actually here. Cool. So now I can choose my solution. Oh yeah. And then I can go down to access control service. Excellent. And then, basically what you manage here are applications. So the thing they call scopes, they just recently changed that. It used to be called applications. So basically, you give every application that you want to use with the ACS a so-called application identifier. Okay? That is typically the URL under which your application is available. This is especially important for that application because they use that URL to do the return to your application. So, I have a simple demo here, just to show you what's going on. Basically, what this, excuse my UI skills, yeah, what this application wants to do is, it wants to support users coming from somewhere, right, and just, wants to rely on the resource STS doing its work. In our case, the resource STS is the cloud-based one. So that's the application identifier. So if I go back to here, you can see I have an application here with that URL. At the moment, the rules engine is empty. Okay? So meaning nobody has access. I can prove that if I try to log on. I get forbidden. Okay? So now, what exactly do I configure in this thing? The first important thing is what they want to know is this token they produce must be encrypted. Okay? So the ACS doesn't issue clear text tokens. That means you basically specify a public key here with which to encrypt the tokens, and you need in your application the corresponding private key to decrypt the tokens again. Okay? That's the first thing you have to do. Then you can basically specify what type of identity issuers do you want to support. And by default, they support themselves and they support live.com. That's why I'm using live.com here, because it's just the easiest way to show it, because it's pre-configured. Okay? So the really interesting thing is the so-called rules engine. And the idea of the rules engine is quite simple. You basically have input claims and you have output claims. And in between, they run the rule. Okay? Before we do that, let me quickly show you an illustration of that, because that's easier to understand. So for example, let's say the input claim coming via some of the supported tokens coming in via one of the supported or registered identity providers could be a claim called department and the value is sales. And we could basically transform that claim to an output claim saying action at customer. Okay, that's basically how you would translate from one claim type to another claim type. Okay, you can basically say, okay, if the guy comes from the sales department, he will get a purchase limit of 5,000, for example. That could be another rule. Or you can basically just, copy input claims to output claims. So let's say someone comes in with a department claim. I want that claim to be existent at the output too. Or I can change claims while copying them, basically saying someone comes in with an Abteilungsclaim, but we need department, so we can, transform them. Okay? So let's do that as a simple demo. So let's say when someone comes in with a Windows Live ID, I wanted to translate that to a standard name claim, and I want to copy the input value. Okay, I just say star here and save that rule. Now what is expected to happen when I run my application? Basically now the application will see my Windows Live ID as a name claim in the application. So let's go back here, click login, and here we are. Okay? So now there are two claims. One is the issuer name and one is the name claim. Okay? And you can now say, okay, let's do that. Let's say when a specific Windows Live ID comes in, and again, Windows Live ID support is mostly for the ISV type of companies which, need flexibility. So let's say when a Windows Live ID comes in with the value of my Live ID, I want to map that to a group called Troopers. Yeah? Okay? So let's log out here. Let's re-authenticate with Live and with the ACS. And here we are. Okay, now we have a Troopers claim. And it gets more interesting. With a thing called, they call forward chaining rules. So let's say, for example, someone comes in with a claim of type department and the value of sales, and you map that guy to a role named customer management. Okay? Now, the interesting thing is, you can take this claim, feed it back into the input side of things, and then say, when a claim comes in with customer management, let's map this to add customer, delete customer, update customer, and so on. Okay? So you can add another layer of abstraction in between that in the end, and that's always the big goal here, the application itself doesn't need to know all that stuff. The only thing the application cares is when you click the Add Customer button, you need a claim called Add Customer, otherwise you're not allowed to. Okay? So let's do this kind of forward chaining rule just to show you how it looks like. So let's say we're adding a new rule. So whenever somebody comes in with the group called Troopers from this issuer here, then let's map him to can break stuff. Okay? So you see now that we are not operating directly on input rules anymore. We are operating on claims that are already generated by the ACS itself. So, can break stuff. Good. That means if I press log out here now and log in again, here we are. Okay? So basically, let's say your application is interested in the can break stuff claim. The only thing you have to do is map incoming users to this group called troopers, and the troopers group maps to claims called can break stuff, can fix stuff, can drink a lot of beer. Cool. That's the basic idea of that. So, there's also a graphical tool to do claim rules. I'll come back to this in a second. But it's a little bit more nicer than the web interface. And the last slide I want to show you is basically for those guys that want to know what's going on. That's basically how the SAML token looks like on the wire. Well, not really because it's encrypted, but showing you encrypted code or encrypted XML is not very interesting. So basically, this XML thing has some features. First of all, there's a digital signature here. And the signature is the one from the ACS, right? From Microsoft Access Control Service, the token is signed by their public key. The next thing is, they say, who is the issuer of that token? And that is basically your solution.accesscontrol.windows.net. Okay? The next thing they do is, they add the application name in the token itself. So when the token arrives at your application, what the application should do is look at the scope name and say, hey, is this token destined for me at all? Or is this someone abusing the ACS to send me a token which doesn't belong to me? Things like that. Okay? And then we have just a section called SAML attribute statement, and in there are all the output claims that were generated by the rules engine. Okay? So that is the technical idea. You have seen how that works in the browser. The last thing I want to show you is when I prepared this talk, I had a conversation with Enno saying claims are such an abstract model, they can model everything you want. Okay? So I said, okay, let's prove that point, and this is a rule set for Bella Padula. Okay? Who is not aware of Bella Padula? Cool. It's an authorization system used by the United States government, and the idea is this: you have documents which have a classification, okay? Confidential, secret, top secret, and you have subjects which want to access these documents, and they also have clearances like confidential, secret, top secret. So the rules is you can, if you are secret, you can read all documents below your level, okay? But you can only write in your own level, or up your own level, depends on the dialect. So I wanted to implement that using the ACS, and that's how it looks like. So here's my identity provider. There's a clearance claim, you can't see it really, but there's a claim coming in called clearance with a value of secret. Then I map the secret claim to a level claim called secret, and then I map the level claim secret to can read unclassified, can read confidential, can read secret. Okay? And only write secret. So basically this engine transforms a single claim to a rule set. So let's show you that. So I have some documents here. And as you can see, some of them are classified, some of them are top secret, and some of them are secret. Okay? And now I have a service which can service these documents. Again, I'm going for the character-based UIs. And there's an identity provider which basically emits my home claims, meaning the claims I send to the ACS. That could be your local Active Directory, that could be IBM Tivoli, that could be Oracle, whatever they call it. Sun.NET SSO, which may be the same thing soon. So the idea is this now. I have a service, I have an identity provider, and I have a client. I'm sorry. So what happens if I press enter here now is you'll first see that the client contacts his local identity provider, gets the token, which includes the clearance claim, and then sends the claim up to the ACS, and the ACS does its rule work and sends it back to that service, and I just print it out. Okay? Fingers crossed. Yeah. So, oh man, I'm not done yet. A little bit better. So what happens here? I'm authenticating with my Windows account against the identity provider, and the identity provider emits one interesting claim for us, which is this guy. Okay? So, now the secret claim goes to the ACS. Let's change that here too. Okay? And now what I get back for a secret clearance claim is read confidential, read unclassified, read secret, and write secret. Okay? And now I can, as you can see, number one is missing, the JFK true story. I am just secret and not top secret. So I can get to my documents. I could show you endless one, but that's secret. And just to prove my point, let's say your local admin increases your clearance level in your local domain by going to some database, I guess. Change that to top secret. Okay? So next time the client opens the application, here's the client. So press enter, I look at the output of my identity provider, and you see this time I have a top secret claim here, okay, which maps to different rules. For example, now I can read wait, no, I haven't pressed enter, didn't I? So now I can read also the top secret document. Okay, just an example of basically the flexibility you get and the idea of this access control service. So there's nothing .NET specific, there's nothing Windows specific, it's just a rules engine that can transform from input tokens to output tokens installed at Microsoft. Okay? Which brings me to the summary. So, as I said, that the last 2 years I've been mainly spending my time talking about authentication systems in companies, and my observation is that the shift to token-based authentication is imminent. Okay? There are a number of dialects and so on, but in the corporate world, WS Star and SAML seem to be the winner. Okay? I mentioned OpenID, that is more like, you know, a hobbyist kind of thing. If you want to log onto your Facebook account, they use OpenID for that. Things like that. Once you buy into token-based architectures, you need some sort of resource STS acting as an adapter between input-output tokens. Okay? Then you have the choice: do you want to run that stuff on your own soil, okay, on-premise, or do you want to buy a service like you're buying your bandwidth, or you're buying, you know, whatever you're buying? And when you decide to run that stuff in a hosted manner, then Microsoft are the first this time. Okay, so for a long period of time they have come out with something which nobody has done before. There are others surely to follow. As I said, nothing is RTM'd yet. You can try it out yourself, and just keep your eye open, because I think in the future we'll see more cloud-based security, utility, computing kind of things. Okay, thank you.
Any questions? Okay, Dominic, thank you very much.
I'll be here all day if you want to talk about that more.
Yeah,
I'll be happy to.
I think a big lesson learned. If it looks like .NET, it sounds like .NET, it isn't .NET.
Doesn't walk like okay.
So thank you very much, Dominic. We will have a 30 minutes break. I think coffee is outside, and at 3:30 we will continue.